Hello, Pre-Cal. Our notes today are titled 9.3, Evaluating Trig Inverses. So we're going to be working with evaluating trig inverses. In our notes today, we are going to see inverse cosecant, inverse secant, and inverse cotangent, which we haven't seen yet. Right? We learned in lesson 9.1 that when we're evaluating sine, say sine of 1/2, sine of 1/2 occurs at several places. And so there would be multiple answers, and actually infinite number of answers to that. But in inverse sine, there are only going to be one answer. And so because we want the inverse to still be a function. And so I've kind of created these little like circles that are representing the unit circle. And I'm going to go ahead and shade in where our solutions are when we are evaluating these inverse trig functions. So for inverse sine, we learned that our solutions would be in the first and fourth quadrant. So I'm going to shade in that area. Inverse cosecant is the same. So I'll shade in quadrant 1 and 4. Inverse cosine. When we evaluate inverse cosine, our solutions will only be in the first and second quadrant. So I'll highlight there. My highlight kind of went over into the other quadrants, but you can see it is first and second there. Secant is the same, first and second. And then tangent is a little bit different. Inverse tangent is in quadrant 1 and 4. But inverse cotangent is in quadrant 1 and 2. So that's something to be aware of when it comes to evaluating. All right, so we're going to be referencing this information throughout our notes for today. If you have a TI-84 calculator at home, if you're using that, you'll notice that there are buttons for inverse sine, but there are not buttons for inverse cosecant, inverse secant, and inverse cotangent. And so we actually have to always represent, if we're going to use our calculator, in terms of inverse sine, inverse cosine, and inverse tangent. And not just when we're using our calculator, but when we're solving by hand. That's what our notes are going to focus on today, but you will see some calculator type questions in your homework. So it's important that even if we're working the problem out, we refer back to inverse sine, cosine, and tangent. And you'll see kind of what I mean in just a second. All right. So we know that sine and cosine, secant and cosine, and tangent and cotangent are reciprocals of one another. Okay, but that's not true for their inverses. It's a little bit different. So we know that inverse cosecant of x. Think about to find the inverse, you switch x and y. So the y value on a cosecant, if cosecant of x equals y, then that y is now the input. And so that input is what we took the reciprocal of. So inverse cosecant of x is equal to inverse sine of 1 over x, which would then equal theta. Okay, so I don't know if I explained that very well just a second ago, but hopefully you can see that now. We take the reciprocal of that input. Okay, and then we can work down the list. Secant, inverse secant of x is equal to inverse cosine of 1 over x, and that would equal theta. And lastly, inverse cotangent of x would be inverse tangent of x of 1 over x, which would equal theta. All right, and there's actually a proof of this. If I start with inverse cosecant of x equals theta, I can take the cosecant of both sides and the cosecant of inverse cosecant of x is just x. So I have x is equal to cosecant of theta. Cosecant of theta is equal to 1 over sine of theta. Sorry. So x equals 1 over sine of theta. And then if I multiply both sides by sine, divide by x, I get sine of theta equals 1 over x. And now I'll take the inverse sine of both sides. And I get theta is equal to the inverse sine of 1 over x. And so that's what I proved, that the inverse cosecant of x equals theta is the same thing as inverse sine of 1 over x equals theta. All right, so you can kind of make a note from the beginning. All right. So that's a proof of it, but you can see how reciprocals work a little bit different. Yes, cosecant is the reciprocal of sine, but the inverses do not work like that. Okay. Inverse cosecant of x is equal to inverse sine of the reciprocal. Okay. So hopefully you see that now through that proof. Okay, we're going to do a couple examples. Example 1, I have cosecant of inverse cosecant of 2 equals theta. And I don't necessarily know what that is, and also my calculator can't do this, but I do know that I can represent this as inverse sine of the reciprocal 1/2, which equals theta. And this is something we would need to be able to do without a calculator. Inverse sine of 1/2 equals theta means where is sine equal to 1/2? But I'm not going to write that down. I'm not going to write that statement I just said because we don't want to get confused. We don't want to think that we're really answering the question, where is sine equal to 1/2? Because sine is equal to 1/2 several places. I know that my solution can only be in the first and fourth quadrant. And so in this case, where is sine equal to 1/2? That would be pi over 6, which is the first quadrant. So theta equals pi over 6. So you can refer back to our quadrants up here. Inverse sine of 1/2. Sine is equal to 1/2 in the first and second, but we know that because we're working with the inverse, it can only be in a highlighted quadrant. Okay? So that would be our answer. Example 2. We have secant inverse of negative square root 2 equals theta. And so we'll rewrite that as inverse cosine of negative 1 over square root of 2 equals theta. And then I'm going to rationalize that. Multiply top and bottom by square root of 2, and we have inverse cosine of negative root 2 over 2 equals theta. So where is cosine equal to negative root 2 over 2? Well, cosine is negative in the second and third quadrant, but I know that the inverse cosine can only exist in the first and second quadrant. So it has to be that second quadrant answer. And that would be theta is equal to 3 pi over 4. So you can see you still really need to know your unit circle and be able to recall these values. I'm not always going to go back to my unit circle in my notes, but you definitely could have your unit circle out. All right, example 3. Inverse cotangent of 1. Inverse cotangent of 1 equals theta. These you have to be really careful with, okay? Because I am going to rewrite this in order to evaluate as inverse tangent of 1 over 1, which is 1, equals theta. And so then we think, okay, well, where is the tangent equal to 1? And tangent is equal to 1 at pi over 4, so in the first quadrant and in the third quadrant. But our original question was, where is inverse cotangent? We're talking about inverse cotangent. And inverse cotangent, our solutions are only going to be in the first and second quadrant. So even though that answer right here was in the third quadrant, so it wouldn't have been that anyway because tangent can't have solutions in the third quadrant. What if my solutions were in maybe like the second or fourth? Well, cotangent, I can only have values for cotangent in the first or second. Okay, so we just have to be really careful with cotangent and tangent because their values are not in the same quadrant. So always think back to the original question. So this would be in the first quadrant, because remember our options are first and third. Cotangent happens in the first and second. So it'd be in the first quadrant at theta equals pi over 4. All right. And that is our notes for today. You definitely want to get to where, or get to the problems in the practice, because there are some problems that you have to use your calculator for, and there's a lot of things you gotta realize when it comes to cotangent and tangent and come across different types of problems. And so it's really important you do that practice, and we will be sure to go over some of those problems in the next class period. All right. Make sure you let me know if you have any questions. That is the end of our notes.